Okay, this is example 13 in the class notes for section 2.4, one-sided limits. And in this example, we just want you to look at this graph here and consider the following graph for this weird-looking function. So we're not defining this with numbers or letters, we're just looking at this as the function of the picture here. So determine the limits as x approaches 0, 1, 2, 3, and 4. So you have to think about a limit as being a two-sided limit. And the way a two-sided limit exists is if both of its one-sided limits exist and it's the same. So what that means is we're looking as x approaches 0 here. So as x approaches 0, as I come into 0 from the left-hand side of 0, notice there is no function over here. So there is no limit as I come in from the left side of 0. So even though as I'm coming in from the right side of 0, the function looks like it's approaching 1, that's only true on the right side of 0, not the left side of 0. So that means that the function, the limit does not exist as x approaches 0 for this function, simply because the function itself does not exist for x less than 0. Now as x approaches 1, notice that as I'm coming into 1 from the left side of 1, the function itself looks like it's going down to 0. However, as I'm approaching 1 from the right side, the function is staying at and approaching the value of 1. So again, these two one-sided limits are not the same. The limit as x approaches 1 from the left is 0. The limit as x approaches 1 from the right is 1. So that means that the limit as x approaches 1 does not exist. What about 2? So as x approaches 2 from the left side of 2, the function itself looks like it's approaching and staying at 1. Don't worry about what it is exactly at x equals 2. We don't care. We want to know what it looks like it's approaching. As x approaches 2 from the right side, the function is coming down and it looks like it also approaches 1. So since the two one-sided limits are the same, the limit as x approaches 2 from the left is 1, the limit as x approaches 2 from the right is also 1, that means that the limit as x approaches 2 of f of x is 1. And again, we don't care what it actually is at x equals 2. So there you can see this written out. At x equals 3, again, and this one's pretty easy to quickly see that we have a two-sided limit that exists because as x approaches 3 from the left, the function is going up and looks like it's approaching 2. Actually, the function is 2 at that value of x. As x approaches 3 from the right, the function is also approaching 2. So we have a two-sided limit that exists. Actually, the function itself is that same limit, but that doesn't matter. What matters is the two one-sided limits are the same. They're both 2. So the double-sided limit, the two-sided limit, the limit of f of x as x approaches 3 is also 2. Again, as x approaches 4, it looks like the function is coming down. When I'm approaching 4 from the left-hand side, it looks like the function is approaching 1. But there is no function on the right side of 4, so I can't even talk about a limit on this case. So since I don't have two one-sided limits that are equal, the two-sided limit does not exist. And that's what we have there.